If your Excel timestamps are drifting by a second or a minute, you're not imagining it. You can type a clean time like 10:30:00, do a few calculations, and suddenly it becomes 10:29:59 or 10:30:01. That tiny wobble is enough to break comparisons, shift buckets, and make reports look inconsistent. The root cause is usually not your formula. It's how Excel stores time as a floating number, plus how rounding works when you convert or format it. In this video, you'll learn a practical mental model for what's happening, and a set of fixes you can reuse. We'll cover why looks right can still be wrong, how to detect hidden fractions, and how to round safely to minutes or seconds. We'll also handle common cases like imported timestamps, elapsed time, and grouping into 5-minute intervals. By the end, you'll be able to stop the drift and trust your time logic again. Next step. Let's build the core model first. Excel stores a date and time as one number. The whole number part is the date, and the decimal part is the time of day. So noon is 0.5, because that's half of a day. 1 minute is 1 divided by 1,440, and 1 second is 1 divided by 86,400. The problem is that many decimals cannot be represented perfectly in binary floating point. Excel gets very close, but very close is not the same as exact. When you add, subtract, multiply, or divide times, those tiny representation errors can move around. Then you format the cell as HHMMMSS, and Excel rounds for display, which can hide the underlying value. That's why two cells can print the same time but still compare as different. Once you accept that time is a fraction, you can fix issues by snapping values to the precision you actually care about, like the nearest second or minute. Next step. A key trap is trusting what you see. Cell formatting is just a mask. If a cell displays 0800, the stored value could be 0.333333332 or 0.333333336, and both might display as exactly 8 a.m. That becomes a problem when you do equality checks, lookups, or grouping. For example, a VLOOKUP or XLOOKUP that matches on a timestamp can fail because the lookup value is off by a hair. Another common symptom is a duration that should be exactly 60 seconds, showing as 000059, or a sum of minutes that lands 1 second short. To diagnose this, you want to reveal the raw number, change the format to a high-precision number, or use a helper like A1-86400 to see seconds as a decimal. If you see values like 3599.99999, you've found the hidden fraction that's causing the drift. Next step. Now let's talk about the most reliable fix, rounding to the unit you need, using seconds as the anchor. If you care about whole seconds, convert the time to seconds, round, then convert back. The pattern is simple. Multiply by 86,400, round to an integer, then divide by 86,400 again. That snaps the value onto the exact second grid that Excel can represent consistently. For minutes, do the same with 1,440. This approach is usually more predictable than rounding the time directly because you're rounding a number that's meant to be whole. Use round for nearest, floor for down, and ceiling for up. Also, be careful with negative times or elapsed time that can go negative because floor and ceiling behave differently there. If you standardize this round via seconds pattern in your workbook, you'll eliminate most drift issues in comparisons, grouping, and exports. Next step. Let's make those formulas concrete. To round a timestamp in A1 to the merest second, use equals round A1 times 8600/400 divided by 8600/400. To force it down to the prior second, use equals floor A1 times 8600/400 divided by 8600/400. To force it up, use ceiling A1 times 8600/400 divided by 8600/400. For minutes, swap 8600/400 with 1440. If you need the nearest 5 minutes, multiply by 1440, divide by 5, round, then multiply back by 5. That looks like equals round A1 times 1445 divided by 5 over 1440. The key is that you're rounding an integer space, then returning to Excel's day fraction. One more tip, if you're going to compare times across tables, Normalize both sides with the same rounding rule. Rounding only one side can still leave mismatches. Consistency beats cleverness here. Next step. Another big source of floating time bugs is importing timestamps as text. CSV files, system exports, and copy-paste from websites often produce text that looks like a time but isn't a real numeric time value. Sometimes Excel converts it, sometimes it doesn't, and sometimes it converts it inconsistently across rows. The fix is to parse and convert intentionally. If you have a clean time string, like 130759, time value can convert it. If you have a full timestamp, like 2026-04-16, 13:7-59, date value plus time value can work. Or you can use a more direct parsing approach with text split in newer Excel. After conversion, immediately normalize with your rounding rule, because imports can include fractional seconds or hidden characters. Also watch for locale issues, like day-month order or commas versus dots. The goal is simple: get to a true numeric date time, then snap it to the precision you want. Next step. Next, let's handle comparisons and lookups, because that's where drift hurts the most. If you're matching timestamps between two lists, direct equality is fragile. A better approach is to compare rounded versions. For example, create helper keys like timestamp rounded to second, and match on those keys. If you only need minute precision, round both to minute and match there. For time windows, avoid checking if A equals B. Instead, check if the difference is within a tolerance, like less than half a second. In Excel terms, half a second is 0.5 divided by 86,400. This tolerance method is especially useful when you're aligning logs from different systems. For grouping, build a bucket key, like time floor to 5 minutes, then pivot on that. The big idea is to decide the business precision first, then enforce it in your data model, instead of letting floating point decide for you. Next step. Now let's talk about elapsed time and durations, because they create a different kind of confusion. A time of day like 1800 hours is a fraction of a day. A duration like 36 hours is more than one day, so it spills into the whole number part. If you format a duration with a normal time format, it wraps at 24 hours and looks wrong. Use bracket formats like H, MM, SS for durations. Drift still happens though, because you might be summing many small intervals. The same rounding approach works. Round the total seconds, not the displayed time. Another pitfall is negative durations. Excel has settings that affect whether negative times display, and some formulas behave differently with negatives. If your durations can go negative, test floor and ceiling carefully, or use round with an explicit sign strategy. The goal is consistent arithmetic, then consistent display formatting on top of it. Next step. Here's a practical workflow you can apply in almost any workbook. Step 1. Decide your required precision. Is it minutes, seconds, or 5-minute buckets? Step 2. Convert all incoming timestamps to numeric values, not text. Step 3. Normalize them with one standard rounding formula, and store that as a clean helper column. Step 4. Base your joins, lookups, pivots, and charts on the normalized column, not the raw imported value. Step 5. Keep the raw column anyway, so you can audit and trace issues. This pattern keeps your logic stable even when data sources change. It also makes debugging faster, because you can quickly compare raw versus normalized and see where drift is introduced. If you share files with others, this helps too, because different regional settings and import behaviors become less dangerous. Think of normalization as a small data cleaning step that pays off everywhere. Next step. Let's cover a few edge cases that commonly surprise people. First, adding 0.1 seconds repeatedly can accumulate error because 0.1 is not exactly representable. If you need sub-second work, Excel is not ideal, but you can still store integer milliseconds in a separate column and only convert to time for display. Second, beware of using text to create time strings and then using those strings in calculations. Text is for display, not data. Third, when you round, you can push a value over a boundary, like 1259.59.6 rounding up to 13,000. That's correct, but it can change the date if you're near midnight. If that matters, round the combined date time, not just the time portion. Finally, if you export to another system, export the normalized value and consider exporting as an ISO-like text timestamp to avoid reinterpretation. Small choices prevent big headaches. Next step. To wrap this up, the fix for Excel timestamp rounding errors is mostly about being deliberate. Excel time is a floating fraction of a day, so tiny errors are normal. The problems start when you expect exact equality at a precision you never enforced. Your best tools are simple: convert to seconds or minutes, round in integer space, and convert back. Then use those normalized values for matching, grouping, and reporting. Keep raw values for traceability, and treat imported timestamps as suspicious until proven numeric. If you do that, the 59 seconds and 1 minute drift issues largely disappear, and your workbook becomes more trustworthy. If you want one rule to remember, it's this: format is for humans, rounding is for logic. If this was helpful, subscribe for more Excel problem solving that focuses on accuracy and repeatable patterns. And for a quick check-in, comment with your usual precision. Small tweaks compound into massive performance gains. Subscribe to catch the next workflow optimization.